In question number 2, we are told that the square is drawn on a 1 centimetre square grid, and we are tasked with working out the area of that square. That's a 3-mark question. It's a pretty tricky one because the square isn't lined up with the lines on the centimetre square grid. So you know, because it tells you up here, that each one of these is worth 1 centimetre squared, 1 square centimetre. So you've got 1, 2, 3, 4, which we can see straight away quite clearly whole centimetre squares. So that part of it in the middle is worth 4 square centimetres, 4 centimetres squared. Now, what we could do is we could split this shape up into some triangles that we've got going on here. So there's a triangle, a right angled triangle. There's another right angled triangle that's exactly the same. And we know it's exactly the same. This length is the same as this length because it is a square, we're told that. And here's another right angled triangle, and there's another right angled triangle. So what you can do is you can take this one, I'll colour in for you, all of the area of that is the same as the area of this here. So what we know, and obviously the same on the other side, so you can take the area of that and say it's the same as the area of that. So what we know is we've got 4 here, we've got 5, 6, 7, 8, 9, 10. So I put X's in the ones that we've got. And there you go. It looks a little bit messy, but you can see all I've done is taken that triangle there and put it here. Taken that triangle there and put it here. So I've rearranged the shape to make it not a square anymore, but it's easier to calculate the area. That's probably the easiest way to answer that question. You could use Pythagoras. I think for question number 2, you want to be thinking about counting squares. And that's the nicest way to do it. So 10 centimetres squared is your answer for 3 marks.